oftentimes what separates each function from the other function, or what's distinguishable between the different types of functions, are their domain and ranges. When we say domain, we're talking about all the possible x values that are in that function. When we're talking about range, we're talking about all the possible y values that are in that function. And there are two different ways to describe it. And we're going to use both of those ways to describe, well, the domain, or all the permissible possible x values, and range, all the permissible or possible y values of this function over here. The first notation that we use, and it's probably one of the most commonly used types of notation to describe the domain and ranges of functions, is something called interval notation, and that's heavily focused on brackets. So what we say is that we enclose non-included values in what we call circle brackets, like these. So they're like really half circles. And when we say like non-included values, most of the time we mean infinity. But when you're talking about, let's say, functions later on that have holes and stuff like that, then it really just means any value that is kind of skipped over or you can't actually grab from the function. So, but most of the time we talk or we're referring to negative infinity and positive infinity when it comes to this. And then we have square brackets like these over here. And these are for points that are included, or points that you can actually see and grab on the graph. And so if I'm going to describe this function over here in terms of its domain, well, this is how we're going to do it. So I could see that the smallest value for your x is at 1. And the smallest value for your y value is at 2. So when I'm mentioning the domain, or I'm describing the domain, I'm going to list the lowest value first, which in this case would be 1. And we're going to put a square bracket around it because I can see that it is definitely an included point, right? I can actually see the point on the graph. So we're going to put a 1, and then we're going to put the highest x value on the graph. Now here, that arrowhead tells us that it actually goes to infinity. And so infinity would actually be the highest value. So I'm going to write infinity here. And it's a positive infinity because it's to the right. But infinity is not an included point. So we're going to close this off with a circle bracket. Now for my range, and we'll put R over here, we're going to do something similar. The range, the lowest y value that we see is a value of 2. And since I can actually see that value on the graph, we're going to put a square bracket around it. And then just like with the domain, this one goes to infinity as well, positive infinity. So I'm going to write infinity here, but we're going to close that off with a circle bracket because it is not an included point. And so the way you can think about each of the values listed inside these brackets is the first one listed is always your minimum value, and the second one is your max value, and that applies to both the domain and the range. Now in set builder notation, which is another common notation, we tend to use less than or greater than signs to indicate non-included values. And then for included values, we use less than or equal to or greater than or equal to. And there's no emphasis on any kind of particular bracket. But we do make sure to state whether we're using real numbers or not. And in the case of most math courses, it's always going to be all real numbers that are used until you get into more complex mathematics. So for a standard set builder notation description, we kind of do it like this. We say that for all values of x, and that's what this part means, where x is all real numbers. That's what XER means, all real numbers, so no complex numbers. Then we often describe the lowest values, whether they're included or not, based on these inequality signs. And so if I'm looking at the graph above, and this is typically denoted with a bracket that kind of looks like a cloud. So you go for all x values such that, and this line over here is such that, x as all real numbers. If we're thinking about the function above, we would say that x is, now we look and see, is it increasing to the right or to the left? In this case, it is increasing towards the left. So we would say that x is greater than or equal to 1. And the fact that we don't give any closing number or indicate any kind of ceiling, this includes anything going to infinity. So we don't actually state infinity inside set builder notation. Now, if we're describing the range, we would do something similar. We would say for all values of y such that y is all real numbers. In this case, the lowest y value would be 2. So we'd say that y is greater than or equal to 2. And then we put these kind of cloud brackets in. So let's say we have this function here where we want to describe the domain and range in both of these notation types. So I'm going to look at the minimum values and the maximum values for both the x and the y. So for the x, the minimum value appears to be at 1, and the maximum value appears to be at 6. And so when I'm describing the domain in interval notation, we're going to write 1 and 6. And since these are included points that I can actually see on the graph, then we're going to enclose those with square brackets here. Now for the range, same thing, we're looking at the y values instead, where I can see that the minimum y value is 2 and the maximum y value is at 6. And so we're going to write 2 and 6, and we're going to enclose those as well in square brackets because I can actually see that these are points on the graph. Now, if I'm going to write this in set builder notation, for our domain, for all x values such that x is all real numbers, we can see that x has 2 included points. We got the first minimum where x is going to be greater than or equal to 1, and x is less than or equal to 6. And instead of writing them in 2 different forms like this, we can actually rewrite this in one math sentence where we could say that 1 is less than or equal to x, which is less than or equal to 6. And this encompasses the entire domain. And so what I would actually do is I would erase this here, and I would just go 1 is less than or equal to x, which is less than or equal to 6, and close that in brackets. Now for the range, I'm going to do something similar. For all values of y such that y is all real numbers, your y value, we can say that it ranges between 2 and 6. So we can say that 2 is less than or equal to y, which is less than and equal to 6. And that would be the way to write your range in set builder notation. Now, something like this might give some people a bit of hesitation because you're dealing with endless arrowheads on each end of the function here. But it is a function because it would pass the vertical line test here. So if I'm looking at interval notation, well, it seems to keep going forever in the left direction, which would be its minimum value. And so forever in the left direction would be negative infinity. And then it also seems to be going forever in the right direction. So that would be positive infinity. Now, since none of those are included values, it's impossible to include infinity. We're going to enclose this with circle brackets. Now, for the y value, it's the same thing for the range, in the sense that this kind of keeps going forever downwards. So it's also going in the negative infinite direction and also going in the positively infinite direction. And so we're going to enclose these both in circle brackets as well, simply because you cannot include infinity. Now, when it comes to set builder notation, whenever we deal with infinity, it is surprisingly simple. So for all x values such that x is all real numbers, when the range in both, or I should say the domain in both directions, left and right, is infinite, then we just leave it as this, x is all real numbers. And the same thing for the range. For all y values such that y is all real numbers, if it is infinite in both directions, you also just leave it as all real numbers. And so by stating that x is all real numbers or y is all real numbers, we are indicating that it is infinite in both directions. For the last example here, we could see that the x value, so there's a minimum and there's a maximum x value, but it actually keeps going slightly here. So we would say that it goes forever into negative infinity and positive infinity. And so there would be circle brackets around here. Now for our y value, however, for the range, we can see that the highest value it goes is to 4. And then it forever goes downwards as well. And seemingly because of these arrowheads, it wouldn't stop. So we're going to say that the lowest value is negative infinity, in which we'll close that off with the circle bracket. But then the highest value, or the max over here, would be 4. And then we would enclose that with a square bracket because it is an actual included point. Now, when it comes to the set builder notation, like we mentioned previously, since this is infinity in both the left and right directions, then we could just write x for all x values such that x is all real numbers. That is essentially just the domain. Since it's infinite in both directions, we just write x is all real numbers. As for our y, our range, we've got y is all real numbers, except that, in addition to, I should say, y is less than or equal to 4, indicating this is a maximum value and it only goes down from there.